Okay, so these are your hints for the take-home quiz. We're going to go ahead and work on this problem here. We're just going to look at this first part here where we're going to find the sine of 2 times theta. But let's go ahead and read the given information and then solve the problem. So it says, if the sine of theta is equal to 5 over 13 and theta lies in quadrant 2, find the exact value of the sine of 2 times theta. So, first thing I'm going to write down is what the sine of 2 times theta is equal to. That is the double angle identity, which is equal to 2 times the sine of theta times the cosine of theta. And so basically what we want to do here is we want to substitute into this spot and into this spot so we can figure out what this whole thing is equal to. Well, we have that the sine of theta is equal to 5 over 13, so that's one thing we don't have to worry about. Sine of theta is equal to 5 over 13. And so basically what we need to figure out is what the cosine of theta is equal to. Well, sine of theta equal 5 over 13 means that we have y over r. We have a y value, we have an r value. What we need to find is cosine. And so let's go ahead and do that. We're told that we are in quadrant 2. And so we're going to go ahead and draw a triangle in quadrant 2 with our y value and our r value. And we want to find the x value. And so we say that x squared plus 5 squared is equal to 13 squared. And we're going to solve for x by some algebra. We got 13 times 13 is 169. 169 minus 25 gives us 144. And when we take the square root of both sides, we end up with a negative 12. It's actually plus and minus, but because we're in the second quadrant, we're negative. And so that tells us what the cosine of theta is equal to. We know that cosine of theta is equal to negative 12 over 13. And so from here, it's a matter of multiplying. And we have a 2 over 1 times 5 over 13 times negative 12 over 13. And that's going to give us, we got a negative 120 over, negative 120 over 169. So, I'll give you guys another example. Let me go ahead and move on to the next page, and let's look at this one here. Let's look at part D only. And we have the given information that the sine of alpha is equal to 12 over 13 for a quadrant 2 angle, and sine of beta is equal to 3 over 5 for a quadrant 1 angle. Find the exact value of, we're going to look at the sine of alpha plus beta. And I have that definition right here. We don't have to worry about remembering it. And so basically, we have a couple of things given to us already. We have the sine of alpha, which is 12 over 13, and we have the sine of beta, which is 3 over 5. So let's go ahead and figure out what the cosine of alpha is equal to. Let's figure out this scenario right here. Actually, I should use red since we dealt with the other alpha in red. Okay, so we have a quadrant 2 angle, which means we're going to draw our picture here, and we have 12, and we have 13. And isn't this the last one that we worked with? I think so. Yeah, okay, so basically when we solve for x here in the Pythagorean theorem, it's going to tell us that this is a -5, right? And so that tells us that the cosine of alpha is equal to a -5 over 13. And so let's go ahead and figure out the cosine of beta. Okay, so we're told that beta is in quadrant 1. And we know that sine is y over r, so we have a 3 and a 5 here. And I don't even need to use the Pythagorean theorem here because this is a 3, 4, 5 triangle. And the 4 is going to be a positive. So we have a 4 over a 5 here. And now that we have all this info, it's just a matter of the algebra skills. So we got a 48 over 60, and then minus 15 over 60. We have the same denominator, which is 60, and we have 48 minus 15, which gives us a 33. And that can be reduced, right? 33 is 3 times 11, and 60 is 3 times 20. So we end up with 11 over 20 for that one there. And let me go through and make sure that didn't make any mistakes. Alright, well, I'm sure you all will tell me if I did. Anyway, hope that helped. I will see you guys tomorrow.